All right, so moving on, let's take a quick look at the bottom. So you're going to be graphing. The scale has been set for you. And I think the one that I'll be going over is 17. So first of all, this is exponential. So when I look at it, I can see the y-intercept where I should begin at 50. So it'll be right here. And then I can see how it grows. So what I need to do is probably make a table. And I've got 0, 50, but I want to see... put some values after x so I can get a better graph. So it's growing by a fifth. So I'm going to take a fifth of 50, which is 10. And then I'll take a fifth of 10, which is 2. And then a fifth of 2 is 2/5. It's about 0.4 when you look at it as a decimal. So I probably won't graph the 3 and the 0.4. I'll just remember that I have this wall that's working on the graph. So I already got 0, 50 graphed. Here is 110, about there. And then I've got 2, 2. The scale is going up by 2, so it's about there. So remember, it comes down. Don't just stop here. You need to keep going above the x-axis. And that isn't anything I've really paid that much attention to. Just remember, you got a wall here along the x-axis. Sorry, I can't make that thinner. It can't go past that. So we haven't had to graph anything else at that point, so it's the only question I've really brought up the wall, the asymptote with it. All right, moving on. So this is the most recent thing that we've talked about, these transformations. And so what's going to happen is you're going to be given a parent function. Okay. Whoops. And if you look below it, they're going to tell you how it changes. So here, this number is out of the house. There are no parentheses, so it's out of the house. So this is the graph of 2 to the x up here on 18. And on A, since it's out of the house, we're going to be going down 3 because of that minus 3. So what I'm going to do is just take some points here that I can clearly tell. There's about 4 of them. And take those 4 points and move them down 3. So 1, 1 is going to go down 3 and end up right here. 1, 2, this point right here is going to go down 3 and end up at 1, negative 1. And then 2, 4 is going to go down 3 and end up at 2, 1. And this point, 3, 8, is going to go down 3 and end up at 3, 5. So what else is going to go down 3 is the wall. So the wall is normally at the x-axis, you know, when y is 0. So now the wall is going to go down here to negative 3. So just something you have to think about. But now I'm going to connect my points. It's going to coast along the wall and then go up. So it should be the same size. It's just in a different spot. And then B is just asking you to do the same thing, except they're just saying f of x instead of the 2 to the x. But this 1 is out of the house, so the shape is going to be going up 1. So again, this point, 0, 1, will go up 1 to 1, 2, or 0, 2. And this point, 1, 2, will go up to 1, 3. And the point 2, 4 will go up 1 to 2, 5. And the point 3, 8 will go up 1 to 3, 9. And again, the wall will also go up 1. So normally where it's along the x-axis, it will go up and be right here. And I'm going to connect my points. Again, it should be the same size, same shape, just up. Okay? So I'll let you take care of 19. Let's move on to the next section. So we've been doing this as our warm-ups in the morning. So for each sequence, we're going to determine if it's arithmetic, geometric, or neither, and we're going to justify our reason. So the one I'm going to go over with you is C. This is neither. We've never had an equation with that many n's. So there's just one n, whether it's regular size or as an exponent, but I guess one reason is just too many n's for us. And that's a pretty good reason. Okay, n's in the denominator. We've never had n in the denominator, so that could be one. All right, moving on. So what we're going to do on the next section is we're going to take a look, and I give you one box, you're going to find the other box. So you will have to determine, is it arithmetic or geometric, and it's definitely one, and then you're going to complete the other boxes. So, for instance, let's start with 21. So I want to see if it's arithmetic or geometric. So 500 down to 100 down to 20. If you can't see what they're multiplying by, it's definitely geometric. Then what you need to do is to find G is you need to take a Y or a term. So for instance, 4, and divide it by the Y in front of it, which is 20. And then that just simplifies to 1/5. So there's your G. But you also need to find B for the explicit formula. And that means, remember, they don't give us the y-intercept. You need to go back one more. So, when I go from left to right, I can see that they're dividing by 5, and that's fine to do, if I just want to get some more numbers. But that means going this way, they're multiplying by 5. So if you take this 500 and multiply it by 5, you're going to get your B, and I'm going to write it over here in the other box, to be 2500. Now I'm going to write the explicit formula. So to find any term, I take B, B, 2500, and G, I'm just going to put them both in parentheses, to the nth power. And then for the recursive formula, to find the next term, I can take the most current term and multiply it by my G, so 1/5, which again I'll put in parentheses. All right. I think what I'm going to do is walk you through number 22. So looking at the explicit formula, I can see that this is arithmetic. I can see that B is -3 and M is 4. So when I go for the first 4 terms, I can write down -3, but it's not considered one of the first 4 terms. That's the 0th term. So what I'm really looking for are the 4 after it. And to get the 4 after it, I'm going to use this M, and I'm going to continue to add 4. So add 4, I get 1, add 4, I get 5, add 4, I get 9, and then I get 13. So this is not part of the first 4 terms. On the test, if you want to include it, you can, but you do need the first 4 terms. If you give me 5, then that's fine, but I need the first 4. All right, moving on. Based on 25, is this our last question? This is it. So based on the recursive formula below, you're going to give me the first 5 terms, and then we're going to write the explicit formula. So first what I'm going to do is just come up with the first 5 terms. 1, 2, 3, 4, 5. Well, I know the first term, it's 3. And then if I look over here, it tells me that to get my next term, okay, I can just take my most current term and multiply it by 2. So that's what I'm going to do. I'm going to multiply this by 2, by 2, by 2, and by 2. And now I'm going to write the explicit formula. So that was part A. So again, for the explicit formula, I can see, it's geometric. And I know my G is 2. But now I got to find the B. And remember, the B is not 3. We will have to backtrack 1 spot. And if they're multiplying by 2 this way, what I'll do is just divide by 2 going to the left. And you can write 3 divided by 2. You could type it into your calculator and get 1.5. But now I'm going to write the explicit formula. So to find any term, we're not using y, I'm going to take b, I'm going to put it in parentheses, you don't have to, and I'm going to take it times g, also in parentheses, but you don't have to the n power. So this is the final part that you need for b. So you do need to finish up this review. You will be turning it on Friday, and you'll get some time to ask some questions in class, but you are also supposed to be using the time in class to ask questions.